Alrighty, welcome everyone. We are doing stats 1. It's actually lesson 3, not lesson 2. So we can cover that on up. We are doing lesson 3 today, all about compound probability. More specifically, we're looking at and probability. Here's your updated calendar. Looking at your calendar, we are on the 19th doing the and. Tomorrow we'll look at or. Then we'll look at some graphs with probability distributions. This is your updated calendar, so the test on Wednesday is correct. We will have that right before spring break with some test corrections and a flex day before we get our break. All right, jumping in, we've seen this slide before, and we're talking about probability. That's the likelihood that an event will occur, and again, that's always when we're thinking about what we want over your total outcomes that you have. That is kind of our magic formula that we are working with. So when we are looking at compound probability, what this is the likeliness of two independent events occurring at the same time. So when we have independent events, that's two separate things happening, and we are just figuring out what the probability is that they will both occur. So we've got a few examples here to the right. Let's go ahead and talk about how we will solve these ones. Here is our kind of scene that we are setting. We have a dish that has 5 red and 4 yellow M&Ms in it, another dish that has 3 red and 7 yellow Skittles in it. And what we want to do is find the probability of these different scenarios. Now, when we are doing and scenarios, you guys, we are always going to be multiplying. So and is multiplying your different options together. Let's talk about what that looks like here. When we were looking at this one, what is the probability of choosing a red M&M? Now, looking at kind of our scenario, we're thinking about the probability of choosing a red. Well, if we want a red M&M, there are only 5 of those ones. We need to figure out how many total M&Ms are in this dish. It's 5 plus 4, so 9. That makes the probability of choosing a red 5 out of 9. Below, now we're looking at Skittles. So this one, we are also aiming for red. The probability of a red Skittle here is 3. There's 3 of those. We need to find the total number of Skittles that we have. It's 3 plus 7 gives us 10. When we're thinking about that probability, this is 3 over 10. Now here's where the compound part comes into play. Now this question's asking us, well, what happens if we want to figure out what the probability is of choosing both, keyword here, both, 2 things happening, a red Skittle and a red M&M. What we are going to do is figure out, well, hey, what's the probability of getting the red Skittle and the probability of getting that red M&M, and then we are going to multiply them together. So we've already found these individually, which is nice. So that red Skittle that we had was 3 out of 10 probability. The red M&M was 5 out of 9. And what we are going to do is multiply these across the top. Now, quick reminder with your fractions, right? We are going to multiply right across the top. So 3 times 5 is 15. 10 times 9 is 90. And that is our probability. Now, we do always want to write this in simplified fraction form, so just double check, see if you can divide stuff out. This one, we can actually divide out 15 from the top and the bottom. So this is a 1 out of 6 probability of being both of those Skittles that are red and M&Ms that are red. Alrighty, let's look at our next one here. So now we're going to look at these 2 different keywords here on the right. The first one is with replacement, and what that tells us is you are going to put something back. So let's say you're taking something out of a jar, you're reading it, you're putting it back in the jar. The sample space or the total does not change. Now, what you'll also see in a lot of our probability questions is this without replacement, which says if you're taking something, you're keeping it, you're not going to put it back. So your total does change. And so let's talk about how that might impact our different probability questions here. This second example we're looking at is the same dish. So we've got 5 red and 4 yellow M&Ms in a dish, and then the 3 red and 7 yellow Skittles. Let's figure out what these ones are asking us. It's saying, what is the probability of choosing 2 yellow M&Ms without replacement? So again, without replacement, that means that we are keeping them out. So I'm going to write, we are keeping out. When we are doing this one, then we are thinking we want to find the probability of choosing a yellow and the probability of choosing another yellow, and then we are multiplying those together. Now, a big thing here when we're looking at this is we are looking at yellow M&Ms. Looking at your yellow M&Ms, we've got 4 total. out of how many M&Ms? 4 plus 5 is 9. Cool. So your first pick is 4 out of 9 options. But now we're taking it out. So now there's only 3 left in that dish out of 8 Skittles in that dish. So that without replacement, again, is changing that denominator, changing our total because we are taking 1 out. What we do now is what we did last time, multiply right across the top. So 4 times 3 is 12. Looking at this one, 9 times 8, that gives us 72. And then again, we want to see if we can divide anything out of that fraction. I want to say this one, we can divide out of 12 from the top and the bottom. Let's go ahead and do it. And we get, 1 over 6. Alrighty, next example here we are looking at is what is the probability of choosing 2 yellow, Skittles this time without replacement. Okay, without replacement again means we are keeping these out. That means we want to find the probability of choosing a yellow, keeping it, and then picking another yellow out. So we are going to multiply those together. The first one, picking out a yellow Skittle this time. There are 7 yellow Skittles out a total of 10. And let's say you pick one, you keep it. Now there's only 6 left out of 9 in that dish. Then we can go ahead and multiply right across the bottom and the top. So this will give us 42 over 90. And we can divide out a 6 from the top and the bottom to get 7 over 15. If you don't love the simplifying part, remember you can always use your graphing calculator if you have one, or if you want to use the digital version of the graphing calculator, and you can pull up that, type in your fraction, and then always do math frac, and it'll give you the simplest form of that fraction. Just a little tip if you want to try that out. Let's take a look at another example here. This one, instead of Skittles and M&Ms, we're going to transition to some coins. So looking at this one, we've got 5 quarters, 6 dimes, 2 nickels. Whenever we're looking at probability, we do always want to start with finding that total. So let's see how many coins we've got. We've got 5 plus 6 is 11 plus 2 more. That gives us a total of 13 coins in our pocket. What this question is asking us is if we randomly select 2 coins without replacement, what are the different kind of probabilities that we can calculate here? So let's go off to the side and do some. This first one, option A, is saying what is the probability you will select a quarter and then a nickel. Cool. So what we want to do is find that probability of choosing a quarter and multiply it with that probability of choosing a nickel. Let's start with the probability of choosing a quarter. So for our quarters, there are 5 quarters out of 13. And we're going to multiply that times the probability of choosing a nickel. Now there are 2 nickels out of, careful, we took a coin out, we took that quarter out. So now there's only 12 coins in that total for your pocket. So now that we've got your 5 over 13 times 2 over 12, we can multiply across the top and right across the bottom. And these ones, I think we can divide 2 out of the top and bottom so we can get it in simplest form. So this is 5 over 78. Alrighty, our option here is what is the probability you will select 2 coins that are not quarters. Ooh, this not is interesting because what this one is asking us for is what is the probability we choose, honestly, anything else. So when we're looking at this one, I always think it's easiest to find, well, what is the probability you choose 2 quarters? And then do 1 minus that because our probability is always out of 1. If we go back a few slides, that intro, our probability is that scale from 0 to 1. So if we know it's a 1 that's a 100% chance of happening, we can take 1, subtract off what we don't want to happen to get that probability of what we do want. So let's go ahead and figure that out. We are going to do 1 minus the probability of getting 2 quarters. So our first order of business here is let's figure out, well, what is the probability of getting 2 quarters? That is going to look like this. We are doing the probability of choosing a quarter and multiplying it times the probability of choosing another quarter. If I can spell quarter, there we go. When we're thinking about the probability of choosing a quarter, let's see, there is 5 total out of 13 of all the coins. And we're going to multiply it times, careful, no replacement. So now there's only 4 quarters out of 12 total. When we multiply it across the top, that gives us 20 over 156. We can divide something out of the top and the bottom, Let's see, I think this goes to 5 over 39. We divide 4s out of the top and bottom. And so what we just found was this is the probability of choosing 2 quarters in a row. Now again, that wasn't exactly what our question was asking us. It wants us the probability that we don't do this. So what our last step is doing is 1 minus that fraction, 5 over 39. Now I know fractions aren't our most favorite thing in the entire world. How can we go about this? Well, you do have your calculator, so you could type 1 minus 5 over 39. Or we can think about making these two similar fractions here. Since this one is 39, we can make 1 be 39 over 39, because that's just 1, right? If you do 39 divided by 39, that's the same thing as 1. And we can do 5 over 39 the same. Why did I do this? Well, now we have common denominators, which makes it a lot easier for us to go ahead and subtract, because we're just going to go right across the top and right across the bottom. So 39 minus 5 is 34. And 39 minus 39, hey, we don't even actually subtract those ones. They stay the same, and that is your final probability. Alrighty, this next one stems off of that same idea. So let's say we have those 5 quarters, 6 dimes, and 2 nickels. Again, just kind of connecting that total was 13. Let's look at this option. So it's saying, what is the probability we select 4 coins from our pocket, not replacing them, and we get all quarters? Okay. Big thing to kind of highlight here is we aren't replacing them. So what we have is a constant decrease of the total. What we want is 4 coins, and we want them to all be quarters. So if we're kind of mapping out what we are calculating here, we're going to do probability of getting a quarter times the probability of getting a quarter times the probability of getting a quarter. And I know I probably sound repetitive, but times one more probability of getting a quarter. So we've got 1, 2, 3, 4 coins we're choosing. And now we just want to go ahead and write down what all of these probabilities are. Looking at this one, the first one is nice because it is straightforward, right? We've got 5 quarters in our pocket out of 13. But remember, we aren't putting them back. So now there's only 4 quarters left in your pocket out of 12 because we took one out. Now 2 have been taken out, so there's only 3 left out of 11. And your last quarter, 2 over 10. What we can do now is multiply all across the top. That gives us 120. And all across the bottom is 17,160. And this is where your math frac button in your calculator is probably going to be your best friend. But I'll just tell you, since this is a video, that it's going to be divided by 120. It'll be 1 over 143 as your simplified fraction. We won't always work with quarters and Skittles and M&Ms. You might see spinner and dice. So let's take a look at what that might look like. Here we're at a carnival game and you are spinning a spinner and rolling a dice, and we are assuming that the probability or the outcome for each probability is going to be the same or equally likely. So what we're going to start with is figuring out what the probability of spinning orange is and also rolling a 5. Writing out kind of our map here, right? We're thinking about what is the probability of spinning and getting an orange. And we're going to multiply that times the probability of rolling that dice and getting a 5. So we're going to find each of these individually, and then we'll multiply them together. Starting with the probability of spinning an orange, looking at our spinner over here, I've got 1, 2, 3 total sections, and I only see one of those be orange. So the probability of you spinning and getting an orange is 1 over 3. When we're thinking about rolling a dice, there are 6 total sides on a dice. There's only 1 5 though, so 1 over 6. Our new kind of part today is now we're going to multiply these two outcomes together and see what we get. Multiplying across the top, 1 times 1, we get 1. 3 times 6 is 18, so your probability is 1 over 18. Second one here, what is the probability of spinning pink and rolling an even number? Okay, we're thinking about the probability of spinning and getting in the pink section. We're going to multiply that times the probability of getting an even number. Cool, let's just pause for a second. How many even numbers do we have on a dice? We've got 2, 4, and 6. So there's 3 total even numbers out of 6 sides on a dice. And looking at that spinner, there's only 1 pink section out of 3. What we're doing is multiplying across. So 1 times 3 is 3. 3 times 6 on the bottom is 18. And this is a fraction we can simplify. We can divide out 3 on the top and bottom, and we get 1 over 6. All right, last slide here, last example. is using a chart or a histogram. When we're looking at this one, we have people's favorite seasons. And what we want to do first is always find your total. So let's go ahead and count up kind of how many total we have. I'm going to zoom in here. Looks like spring, this is 5. Summer, this is 12. Fall was 6. And winter was 10. When we go ahead and add these all up, we get 5 plus 12 plus 6 plus 10 gives us 33, not 30. Let me back up here. Got ahead of myself. 33 total students surveyed. Next, what we want to do is use that total to help us calculate some probabilities. So first thing we are looking at is what's the probability of a randomly chosen student liking spring or summer. Alrighty, when we're looking at this one, this or means it can be one or the other. So let's find the probability of someone liking spring and the probability of someone liking summer. And we are going to add those together. Now, spring was 5 out of 33. And we're going to add that to summer, which was 12 over 33. And when we add, we just add right across that top and right across the bottom because we've got matching or common denominators. So what we end up with is 17 over 33. Last but not least, we've got what is the probability of someone choosing 2 students randomly without replacement whose favorite season is winter. So let's say you threw all these people's names in a hat. You're going to choose 2 out. You're not putting them back. What is the probability you get 2 winters? So let's go ahead and kind of write down kind of your roadmap here. We're thinking about the probability of choosing a winter and the probability of choosing a winter. And we are multiplying in between these ones. When we're thinking about probability of a winter, let's see, we've got 10 winters respondents over 33. And we are not replacing, so now there's only 9 left over 32. When we multiply across the top, we get 90 over 33 times 32 is 1,056. You can use your math frac button, or if you want to try out and to find what the common fraction is, or common factor, between the top and the bottom, you can. Looking at this one, we can both be divided by 6, which leaves us with 15 over 176. Alrighty, and that is compound probability for you guys. There is a Schoology quiz for you to test it out, and I am excited to hear how you do when I'm back tomorrow.